the traditional, ancestral, and unceded territories of the Squamish, Tsleil-Waututh, and Musqueam nations, and we like to acknowledge that fact, and that they also play a very important role, given that these are all coastal peoples, and we share, their desire to, be respectful of the land and the oceans. For those of you who are new to the VMCC, we are an industry-led, all-volunteer-run organization that was established in 2019, and we started launching our events in 2020. It's a very focused organization. We focus on decarbonization of shipping and the ports, and that's it in terms of the green, in the overall blue economy, cleaner ocean space. So it's very much very, very focused, very targeted. We have a number of events over the years. Our flagship event is Green Ship. The Green Ship Conference, it takes place every November, and it's, a very tight group of people between, ports, for the land side, shippers, technology providers, energy providers, and it's a very collegial event, where we hope to get a lot of interaction and, and shared purpose. We also are relaunching a couple of other events, in terms of pilot projects, and that is a work in progress for our organization. And of course, we have this monthly speaker series to be able to get people who, broaden our reach, and have ideas that come to mind that we're not able to fit into our one-day conference. So this is a relaunch of a speaker series, and we're doing interesting things this year. We'll have next month we'll be focusing on C40, the ports. So C40, the Green Ports Forum, is speaking next month. The month after, there's some research on green shipping corridors. April will be H-Tech, which the locals will know is a hydrogen-focused company. That actually may be an in-person event, so that's the work in progress. And then in May, UBC Sailbot. Sailbot is a multidisciplinary project out at the university, led by the mechanical engineering, that they did essentially an autonomous sailing boat that crossed the Atlantic. And the university, that may also be an in-person event, sort of half day. We're talking with the engineering faculty to let them showcase a number of exciting things they've got going. And June is to be determined. We'll be taking a break over the summer and then relaunching in September. So without further ado, I'd like to welcome Peter Wallace from Lloyd's Register, who will be taking over today's presentation. So I will stop sharing. This event is being recorded and will be available on our website shortly thereafter. So, okay. So I'll let you take over the screen, Peter.
Well, thank you very much for the invitation. I'm going to bring up my slides for this. Put it in presentation mode. Presentation. Slideshow. Yeah, there we go. So I like nuclear. This is it's no doubt about that. By way of background, I'm the principal engineer, risk and regulatory advisory at Lloyd's Register. I sit in Houston, Texas, but I report into Halifax, Nova Scotia, and I've been to Vancouver a number of times. Did one of my internships at Caverner Mawson Marine, so that dates me a little bit, and then another internship at Institute for Marine Dynamics in St. John's, Newfoundland. Anyway, this picture is coffee from the secondary heat loop. Is the heat source on board NS Savannah, which is a very important ship in the history of nuclear ships, and just civilian nuclear energy in and of itself. So, like everyone that came from an oil company, you start everything with a safety moment, and the best form of risk management is eliminate the hazard to begin with. And in bunkering, there is all kinds of accidents that happen. They're not always talked about, but this is an example of what happens. The Vancouver Maritime group here is about decarbonization. So if we can go to zero carbon, of which nuclear is one of the few true options on the table, then you're eliminating the problem. So I start many of my discussions with the idea that there are two simultaneous revolutions happening. One is the nature of trade. And this has not been a recent phenomenon. This has been going on for at least 10 years, maybe longer. But it's the nature of trade related to nearshoring, friendshoring, how goods and services move between different countries and different locations. And the basic premise is that 90% of everything will still move by ship, but the what and the where will be different over time, whether it's 2030 or 2050. The other major revolution is the nature of shipping itself. This is more internal. We're looking at autonomous, remote, certain decarbonization efforts, whether it's nuclear or ammonia or natural gas or wind or what have you. Shipping is getting more technical. It's getting more interesting. So what we're seeing is changes in new technologies, reduced emissions. Even though that's backed off a little bit, I don't think that's going to go away. Increasing focus on safety. There's some potential changes in the inspection, maintenance, repair philosophies on the near horizon. There are potential changes in owner-operator structures, and there are potential changes in the supplier-operator relationships, and increasing transparency across the board. So these two revolutions we're walking into at the same time, which means it's a great place for nuclear. And when we get to decarbonization, nuclear and hydropower are in a league of their own. They just nothing better than those two. Wind is great for decarbonization for a lot of things, but it's difficult to do with larger ships. I do see it on smaller ships, smaller vessels, and wind assist is very much a valuable element. I don't know what the current numbers are, but I wouldn't be surprised if you could get 30, 40, maybe 50% of the power from wind on large, slow-moving ships. I promise not to have too many words on this slide deck. This is most you'll probably see. Now you want to take a look at nuclear, and the first thing I say to people is that it will be somewhat different. If you're coming from an offshore background, it will be familiar. It won't be exactly the same, but it'll be very familiar in terms of the very large structures, the emphasis on demonstration, things like ALARP, things about demonstrating equivalency, working with a broad range of codes and standards, but it feels like offshore. The ships, it's a little bit different, and I'll talk about a little bit that later. When we get into what you can use nuclear for, it's not a drop-in replacement. It's not you're not going to drop a 5-megawatt reactor in there in place of a diesel generator. It's not going to work like that. The costs are different, the organizational systems are different, and on and on and on. But we'll talk about that in a second. There are changes that can do things that you never could do before. And then finally, this is not going to work with a fragmented system where you're just handing one thing from one party to another. Everything has to be integrated across the value web. So for a ship operator, why you might be interested in nuclear? Decarbonization, whether it's mandatory or if it's influenced. Some of your customers might want you to decarbonize, even if the U.S. government is not thinking that way. Your customer might be thinking that way. We can arguably get better ships. You'll get safer ships. You'll get better performance in terms of range, speed, power availability, noise and vibration. I think it's going to pretty much mandate looking at longer vessel lives, like 40 years is going to become the norm. The nuclear plants are small, so they look large, but you don't have to have all the bunker tanks and everything around that. Because of the offshore nature, the condition-based maintenance, extended times between surveys or dry dockings will probably be the norm. Fully electric ships. Now, some heat will probably be pulled off for certain services, but largely electric. So propulsion, lights, anything that you had a standalone diesel for or something else, think electric. And we all like the idea of getting rid of routine bunkering operations, which is for those in ports and high tempo port activity, know that this is one of your larger HSSC exposures. You can look at new offerings much faster. You can go around the world. You don't have to stop for fuel very often, like measured in decades. The cost structure will be quite different. It will be more balance sheet CapEx related than OpEx. And so your fuel is now a balance sheet item, which makes it a saleable asset. Your disposal actually has to be contracted when you license building the vessel. And one of those quirks in accounting is that every liability is a saleable asset in its own way. So that becomes saleable because you've already contracted it. Turbo machinery, which is the primary form of power conversion, is great for power by the hour leasing. This is like aviation and more limited in offshore, but it's out there. And then the more capital line items you have, the more leasing financial options you have available. And then for every dollar per ton of carbon, that's an advantage you get for nuclear because its baseline is 0. Your operating model will be quite a bit different. You're probably working with smaller, much more highly trained crews, and that's going to really rework things. And then you'll be under a risk-based or condition-based system for your ongoing repair and maintenance. Some things about the regulations is you'll be looking at the normal things for ships, the IMO flag and port state. For the offshore or nearshore units, you'll be looking at your regulator for offshore systems and coastal state. But then you'll add in 2 others that you haven't seen before, the International Atomic Energy Agency and your National Nuclear Regulator. And for Canada, this is the CNSC. The nuclear regulators really focus in on 3 things they call the 3 S's, the safety, security, and safeguarding. And when they say ALARP, they mean ALARP. It's not a made-up term. So you really have to work on that. And with the safeguarding, that is almost purely an IAEA function, while the safety and security are looked at more by your National Nuclear Regulator. And in Canada, that's CNSC. The nuclear island, where the reactor is, that'll be highly protected, kind of stands to reason. And the safety critical systems will also be protected. Your equivalent offshore would be a safety critical element, but these get, it's kind of a flag that says you have to pay attention to that system or component more than usual. And then cybersecurity is definitely going to be elevated. Unlike regular shipping, and more like offshore, the operator is fully accountable from beginning to end. That includes the design of the unit, and it includes everything from when you design it and license it all the way through disposal. So it's not like a ship. You can hive off certain aspects in terms of responsibility, but the accountability still comes back to the operator. Another difference is the emergency response. Shipping regulations are built on the notion that there is a certain response mechanism that exists around the world. Offshore is very familiar with standing up the entire ecosystem around an offshore facility. So it might sound like a lot to a marine or shipping person, but to an offshore person or culture, it is, this is very expected. The offshore, and I'll include nearshore, especially for our port or landside attendees, this really fits in with high power requirements. So if you need a gigawatt or a couple hundred megawatts, nuclear is very good. Long lives, 40 years is probably starting. You can potentially be grid connected or not. So what we're finding with many ports is that they want to be able to have their own power on their own grid inside the terminal gates or inside the terminal fence. So they would have a grid that goes between operators and tenants, but be more limited into how they connect with the utility. Nuclear has surprisingly good turn down and load following capability. Certain reactors and designs respond about 4 to 5 times faster than a diesel engine, and they can go down to about 7% without any difficulty, and they go to 100% without any difficulty. And like steam, 100% is 100%. It's not like diesels where 80% is really you're maxing out. So you can provide grid stability if you work it in with your utility. And then we see potential for desalination and the rainbow color for blue, gray, green. The rainbow color for nuclear is pink. So you can do e-fuel production with nuclear. That should help, especially with the ammonia and the hydrogen approaches. So nuclear and ships. This is not new. The NS Savannah was delivered in the early 1960s, and it is the first commercial ship with nuclear. And in fact, it's the first civilian application of nuclear power worldwide. So it's not only new, but it's very important. Other ones from following along in the 70s and 80s included the Otto Hahn, which was a German ship. That one failed more on how the German and Brazilian trade was. It was intended for German-Brazilian trade in the 70s that never really worked out the way they thought it was. So policy killed the Otto Hahn more than technology. Lenin is a famous icebreaker from Russia, and it was early on. And then the Mutsu is the Japanese research vessel that had all kinds of problems and lessons learned. Other ships that are worth mentioning are the Sevmorput, which is still around, probably being close to scrap, That's a lash carrier. Operates though with military type reactors, and it's basically a government ship for the Russians. Nautilus, that is the first nuclear in maritime, period. And that submarine is pretty special. It was the first true submarine. It was the first one to go under the North Pole, and it was nuclear. So it's a very special submarine in its own right. And then the navies have them as well. Savannah, back to the Savannah. It's hard to understate the importance of this ship. It was not a failure. It was a failure commercially, but it was never designed to be a commercial vessel. It was a showpiece, and it was basically the centerpiece for Eisenhower's Atoms for Peace program. A very famous speech at the United Nations, and then that became the foundation to form the International Atomic Energy Agency. The other thing the Savannah did was it paved the way for the governments to work out how nuclear-powered naval vessels can visit ports worldwide. So all those protocols were established in the 1960s, and it was it was a lot of work. So the commercial and the naval world of nuclear have benefited greatly from that ship. You can still see it today in Baltimore. You can visit the ship. You can call MARAD or the caretakers of the vessel. I think it's the NS Savannah organization, and they will take you for a tour. Today, I believe that's the Yamal, another Russian icebreaker. And this is particularly important type of thing that Canada is looking to counterbalance is the Northwest Passage and the Arctic. So very much Canadian considerations for icebreaking, and nuclear fits into that quite well because it's remote. And these are high-powered vessels that need a lot of power, which means a lot of energy. One that we see as possibility is a transatlantic ocean liner. So if you have a 250-person passenger liner that goes from New York to Southampton, it could do it in 3 days. So if you're well-heeled enough to fly first class, if you leave on Tuesday and arrive on Thursday or Friday, you have no jet lag. You can walk around. You've got a nice hotel room. You got a nice dining room, and you can work from Wi-Fi. So we see a potential market for something like this. Not very many, but it'd be pretty. I would love to take this ship. In remote power generation, we're doing a lot of work right now with Prodigy Clean Energy. It's a Canadian company. And that's been through some funding through the Canadian government. Ultimately, I believe it's NRCan, but it's looking at build strategies of how to build these using as much Canadian resources or capability as possible. Engineering, fuel, technology, people, infrastructure, whatever can be done with Canada, they'd like to do. I believe they're located in Montreal. So a little breakdown of where we could see nuclear units. Power generation, this is like near shore, whether it's gravity-based or floating, is replace coal plants, industrial process heat, desalination. Everybody's really high on data centers and AI. And then for ports, port power, ship power, and maybe potentially refinery adjacent to refineries. Offshore, deep sea ocean mining's got an interest. FPSOs have a very large interest. Drill ships, they're interested, but they have to deal with the realities of the drill ship marketplace, and then other offshore types. And then ships, we see there hasn't been a ship type yet that we haven't been approached about, but container, cruise, yacht, and specialist vessels are the ones that have been coming to us the most. Power ranges, I'm going to basically say that 1 megawatt electric is about as low as we will really see, but then this goes up to 2 gigawatts or so electric. So there's plenty of power, a lot of power available. We're doing some work with ABB and One Step Power now, looking at power distribution system, power management, power distribution system that is more or less in a range of about 10 megawatts or so up to about 150 megawatts electric, based on all kinds of what's needed for the ship. Pretty boring. Smaller 10 megawatts islanded, and then we see a mix of islanded and shore power, macrogrid, and microgrids. The FPSOs actually, there's serious consideration of putting like one power unit out there, and that could provide power to multiple units in an area. The same could probably be done for a field of jackets out where they're in close proximity to each other. A little bit about what LR is doing, not a lot, but a little bit. LR is working, is a class society, IACS, member of IACS, and so that means it's very integrated into the IMO. And then it's also doing quite a bit of work with the International Atomic Energy Agency. The idea is that at some point LR would become a recognized organization for the IAEA for marine and offshore systems. Some of the groups that we're in are NEMO, IACS, obviously, Atlas, which is the IAEA marine work group that's being stood up, and then WNTI, the World Nuclear Transport Institute. So this week at the IMO, they are considering amendments to the A491 nuclear code, which was adopted in 1981 and hasn't been changed since. It was a beautifully written document, but it certainly reflects philosophy and thinkings from 1975 instead of 2025. Where class kind of sits, or at least where we're putting LR, is a nexus for assurance. And assurance is not, it goes beyond just doing like a plan review or a plan appraisal of looking to make sure that your pipes are routed the right way and you follow the class rules, or certify according to like an ASME B31 pipe standard. It's more than that. It's looking at how everything comes together to make sure the design, the operating philosophy, or the CONOPS, and the inspection, maintenance, repair philosophies, how all those match up. And when they turn from philosophies to becoming a premise to plans, that they're coordinated and they work. It's a lot of work. And it gets harder the more complicated things are. And one thing about in a position like that, we always have to look out for those that are trying to skirt the rules, and we also have to look out for colorful characters and sketchy characters. And anybody who's been in the marine industry for any length of time knows that the industry is full of colorful characters and sketchy characters. Some of the changes I've already alluded to. One is, and one of the major ones is the social license to operate. You cannot operate in an opaque or non-transparent way, or try to be incredibly private. It's not going to work that well for nuclear. You have to be engaged with your with the first, second, and third party public and your counterparties across the board. We don't know exactly how to do that, but what we do say is that if you don't have an engagement plan, start working on it if you're going to contemplate nuclear. Your regulatory is going to include your normal jurisdiction or your normal entities, such as flag, class, port state, coastal state, but you're going to add two more to the mix. One is the International Atomic Agency, and the other is your National Nuclear Regulator. So those two will be involved. And then licensing, I've mentioned that the operator is fully accountable from beginning to end. That's part of the whole licensing construct, is the operator is accountable for everything. And it's hard to say, it's hard to underemphasize that. The organizational systems are going to be more integrated and much stronger, particularly the safety management, risk management, and quality management. Risk management is already in place in some oil companies, but not all. It's rare to find in a shipping company, but your safety management system, we all have that. Your crewing is going to look quite a bit different. We're not exactly sure how that's going to shape up, but it's going to be quite a bit different with definitely a nuclear training component, but then also how are the crew going to be seafarers, not seafarers, or how much is going to be remote, how much is going to be on board? It's hard to tell yet. Cost structure is different, and the end of life, you can't just say I'm going to scrap it. You've actually got to contract it when you go through your licensing process. So how it might look today, a nuclear journey today. There are three threads that we see time and time again as how we might look at it from a strategic level. And your strategy is the value cost framework. Somebody is going to ask this question, how much does it cost? And I'm going to say, I don't know. But if you can get more value than you have to spend, then that delta, if that's a positive delta, the question is it enough for you to be interesting or not? The next thing you have to look at is the organization compatibility. Does your company want to do this? Does your port want to do this? Does your mining company want to do this? If they don't want to do it, no amount of profit margin is going to change their mind. So you have to check that. The next thread is around regulatory engagement and social license to operate. Again, you have to have that public perception, and then you also have to have your customer and counterparty perception. Someone might not like the idea of a nuclear powered ship coming into their terminal, and you have to work with them to figure out what it is, or work through management of change, or setting up certain emergency response mechanisms. Who knows? But this engagement is going to be a lot of effort on the front end. But if you put good effort on the front end, the results generally turn out pretty good. And then again, you're going to have to work with more regulatory agencies and jurisdictions than you have in the past. So that's just adding things. You can't get around it. And then your technical and operations. This is for the people that try to make things work. You're looking at the system architecture. You're looking at the build strategy. You're looking at, that's how the shipyards put it together. You're looking at your inspection, maintenance, repair, how you're going to partner with service or equipment suppliers, and how you're going to work with, in general, with your supply web. What can you leave as a commodity? What do you have to go to specifically to an OEM or a specialist on? And then your organizational systems, as I mentioned before, the SMS, quality, and risk management are going to more than likely get a real workover if you enter the nuclear space. This is not to scale on a timeline, but it shows kind of the steps from an idea on a piece of paper at coffee to when your final disposal. So it's more of an offshore line of thinking where you have your idea on the piece of paper at coffee, then you go through multiple ideas, then you go through pre-feed, concept select, feed, and then you go to FID or final investment decision, and then bring it all the way through. I'm going to show this a little bit more carefully here. Your time scales. Yes, your front end time scale before delivery, much more than a conventional vessel, but not as much as you might think. For an offshore project, a amount of time between, let's say, from feed or FID to first oil is often around 7 to 10 years. And we think that if you're motivated today or in the next couple of years and name a project that would take about 10 years from today to actually deliver something, but you will have to be motivated. A conventional ship, a highly specialized conventional ship, can actually take upwards of 4 years to deliver as well. So that part is not huge. I would definitely suggest trying to get a long life out of it, but I would also suggest that you can move greater periods between dry dockings or refueling. So those little green arrows. So you can actually spend more time out at sea or making megawatts or joules of thermal energy than just going to a dry dock, and then eventually disposal. This kind of represents the, not so much the tempo, but how the thinking works. So when you're thinking through strategic ideas, you got many ideas, not one or two or three, but probably 10 or 15 with different variations. And then you increasingly refine them or down select them. By the time you get to pre-feed, you can't really handle more than about 3. It just becomes too hard. And then you have final concept select and then go into feed or front-end engineering and design. And then after feed, you've got your functional design basically done. You're ready to contract or sign purchase orders. And then you move into detailed design, build the ship, and then commission and deliver. And it's very much a river. And what you want to do is you want to set that river up so you don't have too many rocks or falls in it, and it's just a easy river to navigate. But those who've been in shipbuilding or project delivery know there are always bumps, but I'm not repeating anything new on this. The more better work you can do in pre-feed and feed, the better off you'll be on this delivery part. Then once you deliver and commission, then you'll be moving into first megawatt or first revenue. And then it takes a more circular, well, I wouldn't say circular, but kind of a revolving view. So every day, every year is similar. It rhymes. It's not exactly the same, but you're seeing the same types of patterns day in and day out. You're working on your maintenance and repair, you're working on your terminal operations, you're working with your suppliers, your quality compliance, reporting, safety, crewing, all these things. And you also throw in an element of continual improvement as well. But your quality program will be for enforcing that. But you're going to be doing this for, let's say 40 years. And then finally you dispose of it. So what does success look like? Again, the NS Savannah, and that's a picture in the 1962 World's Fair in Seattle, not Vancouver, but as close as I could find to Vancouver in a picture. And then that certificate on the left is I actually managed to get a hold of that signed certificate, but that is the Port of Los Angeles permitting the NS Savannah to call. So that's what success looks like. Okay, I'm doing all right on time. Get your questions ready. Just a few more comments on this. The reason why I put this image up is because it's very much evokes what I like about Houston. You want to put a man on the moon? We can do it. And those are City of Houston construction barricades. So sometimes you just have to do it. Social license to operate. I mentioned this time and time again, but there are 3 questions everybody asks. And they fall into these basic groups: the safety. They don't want a Fukushima, they don't want a Chernobyl, they don't want a 3 Mile Island. They're very worried that if there's an accident, they want it to be a non-event. If the power goes out, that's one thing, but if you have radioactive exposure, that's something they don't want. Security and safeguarding, those are the more formal terms, but that's the ones they're worried about: the bad guys stealing the material to make weapons and that sort of thing. So security and safeguarding is very much up there. And then waste and spent fuel. That is part of your refueling and disposal program, but you cannot get away from it. Don't try to say it'll be handled in the future. You have to address it early on. These are, 1, they're non-negotiable, and 2, they are primary concern of many regulators. So you have to work with this. What needs to be done as an industry today, or just in general, is the regulatory development is very much on path, but you don't have to wait for the regulations to get here. So let's say with a nuclear corridor, you would have a 3-way handshake. It's called a tripartite agreement. The 2 ports, those are 2 of them, and the flag state. If you come up with an arrangement that meets the requirements or the needs of the 2 port states, whether or not wherever they are or what regulatory form they are, and the flag, then you can trade the ship between those 2 ports without having to get everyone else to sign off on it. Then you can add another port, then you can add another port, then you can add another port. If it's done well and thoughtfully at the front end, then what's agreed to can become the basis for the ultimate the regulations that take shape, whether they're IMO or IAEA or wherever else they may be. The next thing that's important is, and this is especially true for shipping, is the design philosophy and the concept of operations to meet the requirements of nuclear means that a lot of time has to be spent on that. You can't just chunk components together and cross your fingers and hope it'll work. That's not going to fly with the regulators, and that's not going to fly in real life. So this is more of a systems engineering approach. And it's nice to talk about systems engineering where you talk about everything at the front end and bring it down. The reality is it works from the middle out. So whoever that initial team is has to be very knowledgeable about how things work in real life and how they should work, so they can produce or prepare solutions that just make sense. So you really need a professional team to work on that. Adopting an open architecture. NOAK is nth of a kind. FOAK is first of a kind. So if there's an open architecture where you have configurable N of a kind or product or other standardized systems, that'll be a benefit. So it's kind of like if you buy a gas turbine, you go to Solar or to Baker Hughes or Siemens, and you ask for a gas turbine, you don't get any changes on it. You get what you get. And then finally, I would emphasize that you're not looking at risk management. When it's done done as a form of leadership and not on your back foot, but as a forefoot, it can help you. Basically, it will help get you through ambiguous or uncertain situations. Waiting for things to come at you and reacting to events is going to slow you down or stop you. So think about risk as a leadership activity, not a management. But finally, it's basically the nature of trade is on the edge of a revolution. Nature of shipping is on the edge of a revolution, and nuclear, it can be a big enabler for the better. That's just our ad for our Fuel for Thought series. And that's all I have. So I think, yeah, I'm done giving my talk. So now it's time for questions and discussion.
Thank you, Peter. Would people like to raise your hand and we can have Peter address your question? Great. Go ahead, Doug.
How does the cost per kilowatt hour produced through nuclear that's actually used for work? Because I'm assuming a lot of it wouldn't get utilized just because of the constant nature of the production of nuclear compared to the cost of a kilowatt hour used for work that's produced through diesel. I just don't see the economics of nuclear, and I'm trying to get a sense with this information from you. That's whole system costs, your cost of security and so on, added in on the kilowatt hour work costs.
So what we see is we see such a wide range of costs or guesses. I've seen it as low as 10 cents a kilowatt hour. I've seen it as high as 60 cents a kilowatt hour. But basically, if you're in the range of delivered, and that's kilowatt electric, and if you're in the range of, I think, 25, maybe even 30 cents a kilowatt hour, then you're working in niche markets that can work on this. Actually, even for power generation, let's say in the Caribbean, if you can have final delivered kilowatt electric hours in the range of 70 cents, it's workable. But for mainstream, I think around 25 cents kilowatt hour is going to make you competitive, and anything below that is going to make you a hero. Now that's without cost of carbon. So if let's say carbon gets taxed at $300 a ton, that means no, or $100 a ton. That's basically $300 per ton of fuel that you're using, and the nuclear won't see that, so that becomes an advantage. It is really, really hard to answer your question directly. I mean, and I knew this question was coming.
Darren?
Thank you, Peter. That was an excellent presentation. How have there been any current ships that have been scrapped, nuclear ships that have been scrapped, and how have industries handled this? Have there been any learning opportunities from that?
Well, the U.S. Navy scraps quite a few nuclear vessels. And in fact, the U.S. Navy is the largest operator of nuclear power plants in the entire world, not by a little, but by a lot. And they basically, for the submarines, for instance, they take the midsection out at the Bremerton Naval Shipyard or Puget Sound Naval Shipyard down in Bremerton, and then they basically put that in a facility in Hanford, Washington. I don't know exactly where everything else is done, but I believe the Savannah now has been completely decommissioned and emptied of any of those things, and that was handled more in a landside terrestrial fashion. The Russians, we don't talk about what the Russians did or do. Yeah, let's just leave it at that. But it's one of those things where Europe is now building facilities to handle nuclear waste or decommissioning from a coming wave of nuclear plants, whether they be maritime or terrestrial.
And can this nuclear waste be reused somewhere else in any other industries?
Some of it can be. So certain, it's somewhere in Europe, there's at least one or two companies where you can clean the fuel of poisons and other things and add to it. So that's one of the benefits of molten salt is that it can be cleaned of the poisons and added to. But then others, basically you're trying to spend it or burn it up as much as you can. But you can take fuel, let's say if it's triso, little triso elements, it's used or spent completely. And so there are ways to, those things are so expensive, you want to use them up.
Yeah.
In short, yeah. Yeah, you just don't want to throw that stuff away.
Thank you, Peter.
Thank you, Vince. Did you have have a question?
Hello, Peter. Thank you for your presentation. I just want to ask that the form of energy of the nuclear that engine can run. So, is there any cooperation with the engine manufacturer for nuclear energy?
Yes. So currently, nuclear power plants or nuclear systems, the builders of the reactors, whether it's GE Hitachi, GE Vernova, or Rolls-Royce, or BWXT, they form pretty tight relationships with power conversion people. So let's say the Japanese make steam turbines for this. Because that power conversion becomes such an important part of the safety critical or the SSC or the safety critical part of a nuclear plant. You cannot separate the two. We are seeing more interest, believe it or not, from the oil and gas industry. So some of this is increasing. So let's say Rolls-Royce, the naval work. Baker Hughes makes steam power conversion gear. I believe it's in France they make it. So it's increasing, but it's by and large going to be turbo machinery. The supercritical CO2 turbines, those are coming as well. Those are fascinating. They're tiny. So I saw a prototype unit that was this long, this big around in the case, and it produced 15 megawatt mechanical.
Mm-hmm.
It's the second highest energy density or power density for power behind rocket engines. And it's multiples of a Formula One car.
Then the nuclear energy heat up the water to make it the steam, and we use the steam turbine for
Right. Well, the
that.
working fluids can change, but whether it's helium for a high temperature gas reactor or a water loop in a pressurized water reactor, but ultimately you wind up with either steam, which is the conventional way to turn steam turbo generators, or maybe supercritical CO2 as a working fluid for Brayton cycle SCO2 turbines. But basically you're working through turbo machinery. And then if you want process heat, you're again using a secondary fluid. Let's say steam, very high temperature steam that could be used in a process plant, like a refinery or a chemical processing unit.
Okay, thank you for your answer.
Is any more questions? I think we probably have time for one more. Anybody? Yes, Doug, please. Go ahead, please.
So I understand the fuel rods for land-based nuclear are replaced every 6 years or so. Is this also the situation with the ship-based nuclear?
Yes, it depends on the type of technology you're using. So if it's a high temperature gas reactor or a pressurized water reactor, the old fashioned kind, then the fuel rods, they'll be replaced. You want to put them on at least a dry dock center of every 5 years, preferably 10 years. But yeah, it's years out, and then you can replace or move them around. The molten salt reactors, those use a different type where the coolant actually has the fuel built into it. So that is more of an online system to they could feed in fuel periodically. And then pebble bed is also another form. It's kind of funny. It's not really a bed. Looks more like a gumball machine where you've got the fuel elements and then you kind of just drop them into the system over time. And so those are more of continual refueling types like molten salt, pebble bed, and then periodic open up the core every 5, 10, 20 years, depending on your particular reactor and how you used it for your fuel rod type.
Wonderful. I see we're at the top of the hour now. Peter, thank you so much for this very informative and super comprehensive presentation. Now, we hope to see you in Vancouver soon sometime. And to our attendees, thank you for attending, for making this event a success. Please keep an eye on your emails as the invitation for next month's event led by C40, the Green Ports Forum, will be coming out soon. And thank you, welcome, and we hope to see you all at more more VMCC events. Peter, thank you again, and we will have the video link to on the website in due course. Thank you.
Well, thank you, and have a great day.
Cheers.
Thank you.
Thank you. Bye-bye.